Good day. We're going to look at this magnet summary in two parts. Part one will be the magnets, part two will be electromagnets. This is giving you a fair amount of information to go with your previous notes, but it's also important to take a close look at those previous notes. So we know about discovery of magnetism, lodestone, which now we call magnetite. Earlier in notes we gave you 4 magnetic elements, and now we've added dysprosium. So these are 5 strongly magnetic elements, and any of those can be used to make permanent magnets. We know N pole is a north-seeking pole geographically. That's a definition. And there's another definition for south pole. We know the laws of magnetism, that a north will attract the south, a south will attract the north. And if you bring a north pole near a north pole, it'll push apart, and similar for south pole and south pole. Vocabulary that you have to know: magnetic field, lines of force, monopole. You've got to know what those things mean. You have to be able to draw lines of force properly, and you've had practice in the lab and also on worksheets. You have to know, oh, that looks like a typo. Make sure that you put the 1 in there, 1,500 kilometers away. So the Earth is a giant magnet, and so we've known about this for 400 years, it appears. And we know the north end of a compass needle is attracted to the north end of the Earth, so the north magnetic pole of the Earth actually has south polarity. It's a south-seeking pole. We know the Earth's magnetic field wanders and that it is reversed. We also know that the Earth's magnetic field plays a role with the northern and southern lights. We should know the definition of domain, and we should know the domain theory of magnetism is if we have magnetic material, we can magnetize it by aligning its domains. So you could sketch that, you'd put a whole bunch of arrows going in the same direction to show it's aligned. If the domains are scrambled, so you'll put arrows going all over the map, it has been demagnetized. And you should know uses for magnets. So I might say, hey, give me 75 uses for magnets. We should know that magnetizing a material involves aligned domains. And so we had the test tube magnet, we had the induction method, the last one with the iron spike, and we have a magnetizer. Demagnetizing a material, we got to scramble the domains by dropping, banging, heating, or improper storage, such as putting north next to north or south next to south when it should be north next to south. So that's where we'll wrap up part 1, and we'll start part 2 in the next video.